Hello class, this is Jared Cameron, Associate Professor of Engineering Technology at Lone Star College, and today I am going to go through an example problem with you. This is a basic statics problem in which we are determining the magnitude and the direction of a resultant force. And so this is one of two videos that I'm going to make. In this first video, I'm going to show you how we come up with the equations to determine the magnitude and the direction of the resultant force. And then I'm also going to talk about how we resolve forces, slanted forces, into rectangular components, because that's something we definitely need to learn how to do. And in the second video, I'm going to actually go ahead and work out through the entire problem, showing you all the answers. And so starting out, I'd like to talk about what a resultant force is. A resultant force is simply the sum of all the forces acting on a particular body. Another way of saying it is that it is a force from which I can replace all these forces acting on the body and still have the exact same effect on that body. So what we're going to do right now is we're going to assume that the resultant force for all these forces is here. Okay? And I'm going to put an R here as a magnitude, so this represents the magnitude of this resultant force. Now, this force is also going to have an angle that we're going to call an angle theta. Okay? And what we're going to do here in determining the equations that we need to get to find out what this angle is and what this magnitude is, we're going to resolve this slanted force into rectangular components. That means I'm going to have a component going in the x direction, this way, and then one component going in the y direction, this way. Now I'm going to call this component ry, the y component of the resultant. This I'm going to call rx, which would be the x component of the resultant. And as you can see here, we have drawn a 90-degree triangle. Remember, these are called rectangular components because they make a 90 degrees right here. So if we were to have the value for the x component of the resultant and the value for the y component of the resultant, then we could use Pythagorean theorem to determine what this magnitude of the resultant is. Remember, Pythagorean theorem says that if you square the leg and add it to the square of another leg, it will equal to the square of your hypotenuse. Okay? But in our case, our leg is the x component of the resultant, so we're going to square that. We're going to add it to our other leg, which is the y component of the resultant, square that, and that should equal the magnitude of the resultant squared. Okay? So to solve this equation, we just take the square root of both sides. And once we solve for r, we find out that square root cancels out the square. We have the resultant equals the square root of the x component squared plus the y component squared. This is the equation you will use to calculate the magnitude of the resultant force. Now, I'm going to scoot this page over, and we're going to go back up over here, back to our 90-degree triangle, and now let's try to determine an equation to get our angle, the direction of the resultant force. Notice here that since we do have a 90-degree triangle, we can use our trigonometric ratios. If you remember, our trigonometric ratios are that sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and then the tangent of theta, that's going to equal the opposite over adjacent. And so if we have Rx and if we have Ry, then we are going to be using the opposite side and the adjacent side. So we're going to set up an equation using the tangent of our angle theta. So here's the equation. The tangent of theta is going to equal opposite, which is Ry, over adjacent, which is Rx. Okay? So to solve for this angle theta, we have to take the inverse tangent on both sides. So that means I take the tan inverse of the tangent of theta, and I also have to take the tan inverse of Ry over Rx. Okay? So these will cancel, and that will give me theta equals tan inverse of ry over rx. This is the other equation that you will use to determine the angle of your resultant force. Okay, and now I'm going to take a minute and talk with you about resolving slanted forces into rectangular components. That's very important. And so you see what we did here when we had the resultant force, okay, and we resolved it into rectangular forces, okay, one in the x direction and one in the y direction. Well, we can all do this because remember I said that the resultant is just the sum of all the forces, okay? Now this is the Greek letter sigma, it means sum, so the sum of the forces equals that resultant force. And so it follows that if I sum just the forces in the x direction, that's going to give me the x component of the resultant. And if I sum all the forces in the y direction, it's going to give me the y component of the resultant. And so now we have a way in which we can obtain the x and the y component of the resultant. Then we plug those in here and in here to get our angle and also to get the magnitude of the resultant. Now if you want to find the sum of the forces in the x direction, or likewise the sum of the forces in the y direction, how do we do that for these slanted forces that are kind of in both the x and the y direction? Well, we have to resolve those slanted forces into x and y components as well. And I'm going to show you how to do that. So we're going to take this force number 2 as an example. We're going to move down here, and I'm going to redraw that force number 2 here. This force is force number 2, and it has a magnitude of 80 newtons. Okay? Here's the vertical. I think it had 15 degrees on the vertical. I like to do all of my angles from the horizontal, so if it's 15 degrees from the vertical, that means that it's going to be 75 degrees from the horizontal. Okay, knowing that all of this is going to be 90 degrees. Okay, and so I'm going to resolve this force into my rectangular components. So I have one force going over this way, and then another force coming down. Okay, again, notice that we are forming a 90-degree triangle right here. All right. So I can again use my trigonometric ratios to determine what this component is and what this component is. This is the y component and this is the x component. So if I want to find out what F2, the y component of F2 is, okay, I notice that F2 is opposite my reference angle. So that means I'm going to be using that sine trigonometric ratio. And so I'm going to write that equation. I'm going to write the sine of theta, which is 75 degrees, that's my reference angle, is going to equal opposite, so that's the y component of F2, over the hypotenuse. So my hypotenuse here is my original force, the magnitude of that original force, which is 80 newtons. Okay, so that's going to be over 80 newtons. And if I want to solve for the y component of F2, then I just multiply by 80 newtons on both sides, and I get 80 times the sine of 75. Okay, and that's going to equal that. I guess I should write a little bit lower. That's going to equal the y component of force 2. So we have 80 times the sine of 75. Okay, and I do the same thing for my x component of F2. Okay, I'm going to get that by using the cosine because this is the adjacent to the angle. All right, and so I'm going to say the cosine of 75 degrees is going to equal to the adjacent, which is F2x, over the hypotenuse, which is again 80 newtons. Alright, so again, multiply by 80 on both sides, and I get that 80 newtons times the cosine of 75 degrees equals the x component of force number 2. Okay, and so I've gotten the x component and the y component of this force. And so what we would do was for any slanted force, we would resolve them into x and y components, they're rectangular components, and therefore all the forces in the x direction we would sum up, okay, and all the forces in the y direction we would sum up to get y component of the resultant and the x component of the resultant. And then we would plug them into these equations here to get our magnitude and to get our angle. Again, my next video is going to actually go through the example doing exactly that. Thank you very much.